Hey everybody, welcome to night 7 of Lambda School's mini bootcamp. It is our second time using Zoom, and I will just say that we had some slight difficulties with the live stream last night. Something somewhere went wrong where kind of two concurrent classes were alternating back and forth on YouTube. So I apologize to anyone who dealt with that. I apologize if that happens again tonight. We're kind of testing different things to see if we can sort that out. But actually, one second, let me record this so that if that does happen, we still have a copy of it. So I'm gonna press record and then start over. Apologies for the sloppiness on my part. Okay, welcome to Lambda School's Web Development 101. This is night 7. My name is Deandra Ryan Moss, and I am your instructor here at Lambda School. We are on night 7 out of 8 of our 2-week introductory course on web development. So we have tonight's lecture and tomorrow's lecture, and then we are all done. It's been really great teaching you guys. We have 2 very interesting, mind-boggling topics, both for tonight and tomorrow night. So I'm looking forward to getting into that. As with last night, we're still kind of getting used to this Zoom format. So I will say that, just as a little heads up to you guys, I will keep an eye on the Zoom chat throughout. But if for the Q&A at the end, try to actually use the question feature in Zoom. I'll remind you again of that when we get to the end. So tonight we are going to be learning all about classes. Classes are really cool. They're essentially our way of creating our own customized data type in JavaScript. So we've played with some primitive data types, things like strings, booleans, numbers, undefined null. We've seen some more advanced data types like arrays and functions. And tonight we're going to figure out what we do when we want to create essentially our own data type with built-in cool customization. So let me talk a little bit about Lambda School and all that fun stuff, and then we will get into our lecture for tonight. All right, so Lambda School. As you guys surely know by now, Lambda School is a 6-month computer science and web development immersive. So we take people who either are just learning how to program or know some language but don't know much about web development, and we take them from the beginning stages of their journey, teach them everything they're going to need to know for a full stack web development job, and then we get you out in the field and get you hired. So that is what we do in a nutshell. Let me break down a little bit more about what each step of that process looks like. As far as admissions goes, we have 2 steps to our admissions process. First, we do a little admissions challenge in which you do coding. Everything you've learned in this bootcamp should prepare you for that. And then the second part of it is we do an interview. The interview is not technical. It's more oriented towards making sure that you're a good fit for Lambda School. We want people who are serious about coding. We want people who are dedicated to the class, people who are going to work effectively with others. So don't worry too much going into that interview if you feel like you don't know enough, because we're confident that we can teach you everything you need to know. We just need to know that you are someone who is ready and able and willing to learn. After you're in Lambda School, you get to learn all sorts of cool stuff. So that means front-end web development, back-end web development, taking all the topics that we've covered in this course and just completely building off of them, as well as topics that we haven't even seen yet, like databases and APIs. So we do this full web development course where we're learning all these languages and details, learning some frameworks that go on top of these languages, as well as working on projects where you can practice really getting the skills down. And beyond web development, we want to round you guys out. So we also teach you a few other good computer science-y things, like we explore some Python. Python is great for manipulating data. It's very similar to JavaScript in a lot of ways, but a great skill to learn and gives you access to some other useful libraries. As well, we go into some C, which is a more traditional object-oriented language. So you come out the other side a really well-developed programmer. And then at that point, we're ready to send you out into the world to show the industry what you've got. So we have a full hiring team that's going to help you build your resume, prep for your interview, and even sometimes connect with companies. And once you are out there and hired, you not only get to use your awesome skills to start an awesome new career, you also get to pay us back your tuition, because to start Lambda School, you do not have to pay us anything. It is totally free upfront because we want to make it available to everyone. So once you're out in the industry, you will, once you have a job making 50K or over in the computer industry, you'll have to pay us back over the first 2 years, a portion of your income. So that is our way of making this education really accessible to you and putting the risk on us, because you don't have to worry about not getting that job and not being able to pay, because you only pay once you have the job. Well, that is Lambda School in a nutshell. And if you guys are ready to get started on that first process of applying, reach out to Karen Zachary in Slack. But before you do that, let's learn about classes. So before I get into actually sharing my screen and programming, I want to have a little high-level chit-chat about objects. So some of you might have noticed that I've used this word object throughout last week and this week in kind of almost two seemingly contradictory ways. So last night we learned what the data structure an object is. It's the thing that you declare with the curly brackets, and then there's the key value pairs inside of it. That is an object, right? But I've used this word object before. And if you guys have been paying close attention, you might have noticed this, that since day one of JavaScript, I've been saying things like, we can create a JavaScript object like a number, or different JavaScript objects have different properties. So there's kind of two different ways to use this word. One is to refer to explicitly defining the thing with the curly brackets, and the other way is more of this general and a broad umbrella term for any type of data in JavaScript. And you might be thinking, well, that is obnoxiously confusing. How do I know which one you're talking about, the curly bracket thing or just the umbrella term for everything in JavaScript? Well, it turns out that there is a reason that those two things share the same word. And that's because everything in JavaScript is an object. And what I mean by an object is I mean the thing that we learned how to create last night. The thing with the curly brackets and the key value pairs, everything in JavaScript is secretly an object. So you've heard me correct. Strings, actually objects. Arrays, secretly objects. What about Booleans? Yes, also secretly objects. Everything, every single data type that we have learned behind the scenes is an object. So we can think about this using this metaphor of a theatrical performance. So we could say that everybody on the stage is an actor, but they're wearing different costumes. You know, one person might be wearing the costume of a villain or the costume of a knight or the costume of a king. So these costumes give them kind of extra features, you know, things like these methods that are particular to arrays. Only arrays get those. But behind all that extra fun array stuff is an object. And behind all of that string stuff we've seen is an object. So when the creators of JavaScript were programming out all these things, they were actually using objects to build up what do we mean by an array, what do we mean by a string, et cetera, et cetera. So we kind of, that secret objectness is kind of hidden from the user, which makes it easier to use the language, but it's something that's going on behind the scenes. And that little weird piece of knowledge I've just dropped is going to be the key to figuring out how to build our own types, or as they're called, classes. So this idea is pretty weird and pretty abstract. So if you're kind of scratching your head right now and saying, I don't know what she's talking about, don't worry, because we are going to come back to this again and again throughout the night. And I think that as we dig into how to build classes, it's going to start to make more sense. And then at the very end of the lecture, we'll bring everything full circle and look a little bit behind the scenes on things like arrays and strings so that we can see exactly what is going on there. All right, so enough of me dropping crazy abstract ideas about everything secretly being objects. Let me share my screen. We're going to create some classes tonight, and then we will bring everything full circle at the end with this idea. All right, let me share my screen and we can do this. All right. Let's go ahead and talk about this little object that I have on the screen for us. So we'll use this as an opportunity to review how objects work and then to dive into our topic for tonight. So I have created an object called Ninja Assassin. We can tell it's an object because I used our friends, the curly brackets, to declare it. And within this are a bunch of these property names and values with the method at the end. So we have this property name called code name. I've set this equal to a string containing deadly sapphire. We have a weapon over here, and that is set equal to the actual weapon name. We have this stealth value, which is set equal to a Boolean value, head count, which I've defaulted to 0 because we're creating a new assassin, so they have to start at 0. And then finally, a method. As a reminder, just regular values inside of an object would be called properties. And we would call this a method because it is set equal to this anonymous function. So methods are functions. So inside this function, I'm using the this keyword to grab my head count property and then increment it. So let's see what that looks like in practice. If we look inside of this, then we can see all the values in here. They've kind of shortened the actual kill function. We can also look up individual items in here, like our code name, caps lock. Sorry, I don't want to use bracket notation. I want to use dot notation. Okay, we run this and we can look up individual values, and using dot notation, we could also call our kill function. So as a reminder, when we're calling these methods, we call them with a parentheses because they are functions. And then afterwards, we could check our head count and we see that it's been incremented. If I called this several more times, we would see it incremented all the way up to 3. So that is a little summary of everything we learned last night: how to create objects, how to access items, call methods. As we know, there are a few other fun things we could do, like loop through or add extra properties, overwrite properties, but I will leave that to you guys to review on your own. So here is this awesome Ninja Assassin object that we have created. So let's say that we wanted to create ourselves a new object. This one is going to be a different type of assassin, because what's better than one assassin? 2 assassins. So I'll give this one a code name. I will give it a weapon. This one is not going to be stealthy. We still want to default our head count to 0 and keep our kill function the same. So now we have not 1, but 2 assassins that we can use. So we can kill with either of them if we want. So when we run the kill method on this one, we see the same thing happens. The head count increments. But what is better than 2 assassins? Well, of course, 3 assassins. So let's create another one. All right. This one is going to be a ghost assassin. We want to go in and change the information on this one to be a little more spooky. Definitely stealthy. And as always, we default our head count to 0 and keep our kill function the same. So if you guys have been paying attention to my golden rule of programming, then you might have realized that I just violated it. So this is not dry. We always want our code to be dry. For one, it just takes more effort to copy and paste things and change the values. 2, it's just a bad way to go. Let's say that I wanted to change this so it was actually called kill count instead of head count. Well, I'd have to change it in these 2 places, but then I'd have to change it in these 2 places and these 2 places. And if I had 8 more of these, I'd have to change it in 16 more places. Not good. That is why we don't want repetitive code. So whenever you catch yourself doing something like what I just did, copying something and then pasting it and then just tweaking a few things, that is a sign that you are not writing dry code, and you should take a minute and ask yourself, is there a better way to do it? In this case, if you're copying and pasting a bunch of like objects that have either similar or the same keys and maybe some of the same values, but other values changed, that is a sign that you want to create a class. So a class we can think of as being a customized JavaScript type that we ourselves create. So instead of just copying and pasting and creating a million different assassin objects, we can actually create an assassin type. So we could think of it as being, we're going to create a rule book for assassin. We're going to create a list of instructions for how one goes about creating an assassin. And then we can use that rule book to streamline this process and just create assassins willy-nilly, which, you know, we've got a lot of enemies. Being a JavaScript programmer is a dangerous job. So we have to make sure we have a lot of assassins on our team. So this is important stuff. Okay, so let me show you how to do it. So this is another, as always, you probably noticed this pattern that I like to start the lesson with a what not to do example. So now let's go into doing it the right way. So let's create our assassin object. And so this thing isn't any one particular assassin. So don't think of this variable as referring to a single assassin. Think of it as referring to a set of instructions for creating assassins. We talked about this a little bit in the Q&A last night, where, for example, there's an object called array built into JavaScript. So if we had this array of assassin names, etc. Sorry. I'll just do two because I'm lazy. So if we had this array of assassin names, this is a particular array. This is what we would call an instance of an array. It's one particular array. Whereas this object, array with a capital A, is what's called a constructor. You see, even in Replit, the little thing floats up saying constructor. So we have this array constructor, and this basically tells us how to create an array. So same thing is going on down here. We have this assassin object that we're creating, this constructor, and this will tell us how to build an assassin. So before I get into the actual meat of it, let's talk about what's going on here. Notice that syntactically, this is very similar to declaring a function. I've used the function keyword. I'm actually going to put some parameters in here in a minute. So this looks almost exactly like a function. The only real difference is that I've capitalized this variable name. Notice that so far, we've never really capitalized our variable names. We've always used lowercase or camel case. This is a JavaScript convention. So once again, when I say a convention, what I mean is that it's not something that's like going to throw an error if you don't do it, but it's something that we always do to cue to ourselves and our other developers what we're going on. And it also looks like I spelled sapphire wrong, so let me fix that. Thank you guys for fact/spell checking me in Slack, or in Zoom. We're not in Slack anymore. Okay, I'll also probably leave S's out of the word assassin before the night is over. Okay, so anyways, back to our constructor. So it looks like a function, but there is this one convention difference that we do, which is that we capitalize assassin. And that's our way of cueing that it's a constructor. Notice that my array object and my object and my string object, all string, not sting, all are capitalized as well. So that is something that we always want to do when we're writing a constructor, is capitalize it. Beyond that, the syntax is going to look very similar to a function. So we do want parameters, and we can think of our parameters in a constructor as being the things that are going to change. So things that, you know, when I was copying and pasting, I changed between the different instances. That's what we would think of as being the parameters. That's the input that we'd have to put in when creating a new assassin. So we know that we always change our code name. We always change our weapon. The stealthy value could be either true or false. And everything else is pretty fixed. The head count always starts at 0, and the kill function is always the same. So these are going to be our 3 parameters. Let's see if I can get this all on one line. Oh well. Okay, so now let's actually write this. So what we're going to be doing inside of here is actually defining the properties. So we want to define out every property we're going to put on each of our instances, and we'll use the keyword this. So this dot code name, this dot weapon, this dot stealthy, and this dot head count. I am actually going to skip the kill method for now, so bear with me. We're just going to kind of breeze over it, and then in maybe 10 minutes, once we've gone over this part, I'll come back and show you guys the best way to do that. So ignoring our method temporarily, I have defined out 4 properties here. So one thing that's a little confusing when you're first learning constructors is that notice that some of these properties match the variables here. That is often happens, but isn't necessary. So if I just abbreviated these parameters to C, W, and S, then this code wouldn't change. We would still say this dot code name because we are defining the name of our property. So this should match exactly what we want our property name to be inside of our final objects. And we always want to put it on the keyword this, because I'll talk more about the keyword this as we go, but think about this as referring to whichever instance we create. So the word keyword this is this really flexible keyword that we have to work with. So we attach these property names on the keyword this, and then we want to actually define them. So we want to default our code name to whatever the input is, whatever was passed in as our code name parameter. Same with the weapon, same with the stealth value. The head count is going to start at 0 every time so we can hard code that value in. So we only want to hard code a value in if the default should be the same on every single instance. So this refers to that parameter that's being passed in, et cetera, et cetera. So if I actually went ahead and typed this out as code name, I would have to change this. And you'll see this constructor code that looks like this very often. So you'll see that there's kind of this weird thing where we have this dot code name equals code name, this dot something equals something. Just to get it straight, whatever is on the left side, whatever is attached to this with the dot notation will be our literal name of our key, the name of our property when we create instances. Whatever is on the right side should just refer to whatever the value is. So in a lot of cases, it's going to be a parameter name. So I'll keep these as their abbreviated forms just to kind of drive that point home, that the things on the right side refer to our parameters, the things on the left side refer to our actual key names. So that is it. Once again, we have kind of skipped over the method for right now, but everything else is put into place. That's all we had to do. So you might have noticed that there's another way that this is a little bit different from a function, which is there's no return value. So really we're thinking about returning this object here, but we don't have to actually type out return this. When we construct it, this is going to be understood. And we'll talk about this more in just a second when I actually show you how we use this constructor. So let's go ahead and create some assassins now. This is the fun part. So I want to create my ninja assassin using my new assassin constructor. So let me pass in Sapphire spelled correctly. And true for stealthy. So let's take a look at this bit of code. In this case, we're instead of assigning the constructor like up here, we're using the instructor. We are calling the constructor to actually create an instance. So let's define that out up here. So the constructor is a rule book for the class. Whereas down here we have instances, which are individual instances of the class. Okay, so we have called our constructor just like a function with our parentheses, and then we pass in our arguments. These are arguments because they're actual specific values. And then we save that into a new variable. So the only difference here between just calling a regular function and calling a constructor is this keyword new. This keyword new is pretty critical. This is our way of indicating to JavaScript that we are calling a constructor instead of a function. So remember how I said that we don't have to write a return statement here? This thing will have a return value even though we never wrote the keyword return. That won't work with a function. So look what happens when I leave off new. Let's see what's inside Ninja Assassin. So it is undefined, and we should expect it to be undefined because if we don't write the return keyword on a function, then the function call won't return anything. But notice that if we add the keyword new, now it totally returns that object. So we've created an object over here using the keyword this, and then we've kind of secretly behind the scenes returned it by using this keyword new. So that is why we always want to use the keyword new with a constructor. So there we have it. Barring the method that we've kind of left off temporarily, we have created an exact copy of this object using instead of explicitly writing out, using a constructor and then calling that constructor. So let's go ahead and create our other two assassin friends. Is it character assassin? So there is some of this kind of copy and pasty style stuff going on here when I'm creating these instances, but notice that sorry, I'm trying to type and talk at the same time. But notice that we're using a lot less code and a lot less repetition to do it this way. Okay, so now we have created all three of these guys. And as we know in Replit, the thing that appears in green over here is only going to be the last line of code. So I'm going to throw in some console logs so that we can see all three of these guys and make sure that they showed up as expected. So one more moment. All right, let's run this. And we see over here in white on the console, all three of these pop up. So all three of these guys have popped up. That means we have successfully built all three of these. So it just, even though it's wrapped here, it's really just taken one line of code for each assassin. And what's really cool about this is it is scalable, which means that we could create 100 more assassins and it would just be one line of code for each new assassin we created. So really useful thing to do, especially when you think about some big production piece of software. For example, Facebook, they undoubtedly have a constructor somewhere defining what a Facebook user is. And there are tons of Facebook users. That would be crazy if they had to write out a new object explicitly every time someone signed up for Facebook. And one question I just want to address right now, which is I'm seeing a question about why is it in Replit that only the last line of code appears in green? That doesn't have anything to do with JavaScript. That's just Replit's design choice. So if every single line of code popped up in green over here, it would probably be really busy and hard to read. So that's just a design choice they made to give you some feedback, but not overwhelm you, I'm assuming. I think it works pretty well, but it can be a point of confusion when people are new to Replit. So wanted to clear that up real quick. All right, back to assassins. So we have our 3 assassins now, and everything's looking pretty good. They contain all their values. We've assigned everything up here. We don't have to explicitly write it out, but we have not added our kill function yet. So those are pretty wimpy assassins if they can't do any killing. So let's do that. There are 2 ways of adding a method to a class. And I'm going to show you the not the best way first. So we could, just like we've done here, write in our kill method. So just like we've added all the other properties, we could explicitly write these out. So let me go ahead and do count ++. Okay, so I've gone ahead and put it directly in the constructor here. And this seems all fine and good. Let's make sure it actually works. So let's do some killing over here. Let's have our ghost assassin kill a couple people. All right, so let's see what happens. Cool. We see that our ghost assassins head count is up to 2. We can see that our ninjas head count is just at 1. So that is great. It looks like our kill function is working. So then why is this not the best way to do it? Let me tell you. Because of what we've done, because of explicitly writing this method into the class, into the constructor, here's what happens every time we run the constructor. So on line 15, we run our constructor, and what we do is we create a copy of the kill function. This runs lines 8 through 10 up here run, and they create a copy of this function somewhere in memory and attach it to this guy. Then we run line 16. This creates a second copy of this function, stores it in memory, attaches it to this object. As you might imagine, when line 17 runs, a third copy is created in memory and then saved onto that object. So let's go back to this like Facebook example. So if there's a method on a user, for example, like a post method, we might have something like that behind the scenes at Facebook, and we have hundreds of thousands of users, that means hundreds of thousands of this method stored in memory. And for every single method on the user, there's a brand new copy. So that is a bunch of copies of literally the exact same thing. This code does not change from user to user or from assassin to assassin. So we've copied the same thing over and over again in memory. That is a waste of memory. Memory is not too expensive, but when we start to scale, it's something we need to think about. So as responsible crime bosses who have a bunch of assassins in our employ, we need to make sure that we're keeping costs down. We don't want to waste memory on creating a bunch of different copies of this kill function. So as it turns out, to get around this, there is a better way to create methods. So we don't like that. We're going to comment it out and do something better. Okay, so every single constructor has something called the prototype built onto it. Prototype. Almost as hard to spell as assassin. I swear I know how to type, you guys. I think I would have learned to type better after being a programmer for so long. Okay, so let's look at this prototype. I'm going to console log it and we'll see what this thing actually is. So it's that first log up here. It is an empty object. So by default, whenever we have this, have a constructor, there's going to be a prototype that lives on it. This is just a property, and the property by default is set equal to this empty object. Not very exciting, except it is very exciting because there's some cool hidden stuff going on with our prototype. The prototype, now I have to spell prototype again, is a hidden bank of communal methods, or maybe not of, but for, because it starts out being empty. So this is this hidden cache where we can put all of our communal methods. So all these things that we want to avoid creating a new copy on every single instance, we can store them instead on the prototype. So let's go ahead and just pop something new on here. So we have kill. Yes, that is the function we are trying to do. And then I'm just going to steal the code from over here because I'm too lazy to type it out. Sweet. So now we have put this on the prototype instead. Once again, the prototype, it lives on the constructor. So it lives on the rulebook, not on any instance. And it's a place where we can put communal methods. So now we have created one copy of the kill function, and we will never again create another copy. This one copy will be communally used by all of the instances. So first of all, I want you to notice something, which is that the instances do not physically have a kill method on them. If we console log the 3 of them, we can see that not one of them has a kill method living on it. And that's accurate. There is no actual copy of the kill method on each of these, because if there were, then we'd have a bunch of copies. But let's see if it works, because that's what we really care about. So if we have our character assassin kill a couple people, and we run our code, notice that it's worked. the head count has incremented up to 4. And that's because JavaScript has some cool stuff going on behind the scenes. When a method is called, the first thing that happens is that they're going to, so when I run line 24, the first thing that happens is it checks the character assassin object for a kill method. So we go ahead over here, we go to the character assassin and we say kill method, kill method, kill. Nope, there's no kill method. If there were one, it would run it. But because there's not, it's going to do something interesting. So instead of just giving up and saying there's no method, it will now check a second place. It will now go ahead and check the backup location for methods, which is this prototype. And it does find the kill method in prototype, so it runs it. So if this were not here, let me comment this out, we would get an error. Character assassin.kill is not a function because it doesn't exist anywhere. It's not in the object, it's not in the prototype, it doesn't exist. But if it's in the prototype, we can still use it. And this brings us to why the keyword this is super important. So the keyword this is this flexible keyword. So notice that we don't know who we're going to be calling head count on. So in one case, it might be character assassin. In one case, it might be our ninja assassin, et cetera, et cetera. So the value of this will change dynamically depending on who called the method. So the this keyword is actually really tricky. It's one of my least favorite parts of JavaScript. It's really useful, but it can be really confusing. So in just this, this is kind of just one simple example of how we might use it, and it can get a little more complex. But here's a good rule of thumb for figuring out what this refers to. When we call kill, when we call any sort of method on an object, in this case, character assassin, we always know what we're calling the method on because it's on the left side of the dot. And when we do that, we can go up to the method and replace this with whatever we called it on. So whatever is on the left side of the dot here is going to be on the left side of the dot here. So this is kind of like this mysterious placeholder. Think about it as like, you know, when you go to the carnival and there's like the cardboard picture with your face missing and you can stick your face in and take a picture. That's what this is like. This is like a poster where the face is missing, which means that all these different instances can come along and stick their face in and use it. So a little bit of a weird memory tool for how to think about this. So there we have it. We have fully created our assassin constructor. We've defined out, let me get rid of all this nonsense. We've defined out all 4 of these properties inside of the assassin constructor. We have used the prototype to define a method in a way where we're not wasting memory. And then we've created all 3 instances. And notice how much less code that took than everything down here that I did at the beginning. So let's get rid of that nonsense. It's not a good way to do it. And furthermore, it would get so much more useful as we scaled up. So, you know, if we created 50 more assassins, that's only 50 more lines of code instead of like 7 lines of code for every single assassin. So it's scalable. It makes it really easy if we want to add a property or change a property name. We just have to do it in one place instead of going through and changing it in every single place. So that is a constructor for you guys. Let's go ahead and take everything we've learned and bring it full circle to what I talked about at the beginning of this idea of everything is an object. So we've just gotten a direct sneak peek into how we might use a constructor to kind of define out our own objects. So behind the scenes, we can create objects with different properties. We can add methods. You know, I've only added 1 method, but we can add as many methods as we want here. We can also create instances. So this is kind of a behind the scenes look at some of what's going on when the JavaScript developers were actually creating data types, things like strings or arrays. So we can use this knowledge to kind of hack into what JavaScript is up to. So I'm going to kind of move all of this to the bottom because we'll probably want it for the Q&A. And let's play around with some of our familiar data types. So for starters, let's look at the constructor. So I think that I'm a little suspicious that we won't be able to look at the prototype. And let me get rid of all of my console logs. All right, unfortunately, Replit doesn't want to look at the prototype, but there is a way around it. So let me go ahead and open my console here. Apologies for the small print. Everyone make your screen full size. So let me look at, first of all, we can see that we have array and object and string and Boolean. These things are all global objects. So the constructors for all our familiar data types exist hidden in here. And as you might imagine, we can also look at their prototypes. So within the, for example, array prototype, we can find every array function. So we've seen the documentation online that tells us about these, but now we're looking at where they actually live. So every array method that you're used to using, or plenty that you probably haven't seen yet, are all hidden inside of this array.prototype. So we can see that array.prototype exists, and it's the place that we store all these collective methods that any individual array might use. The same thing is true if we look at the string prototype. We can see all of our string methods hidden inside of that prototype. So now that we've peeked inside, let's use our knowledge to do some fun stuff. Let me close out my console. Okay. So what could we do with the array prototype now that we know it exists? Well, a useful thing we might do is actually add a new method. So let's say that we have some sort of bit of code where we're actually, here's a good example. We were talking last night in the Q&A about trying to grab the last item off of the array. We know that if we pop the last item off the array, we'll get it back, but it'll be removed. What if we just want to retrieve the last item without actually removing it? Well, we could create our own method on arrays. So I'm going to call this method getLast. And we'll start by finding the index, which is going to be this dot length. Remember, this will refer to whatever array we're calling this on, or sorry, this dot length -1 because of 0 indexing. And then we can return this at index I. So I've used the this keyword first to grab the length, subtract it by 1 to find the last index. And then I'm returning the item at that index. So this is now a communal method that any array can use. So if we create an array, and I don't know why there's an extra 5 there. So let's try it out. I'm going to do array.getLast. Uh-oh. Oh, yes. Let me console log it so we can actually see what's in here. So the reason I'm having to console log this is because we have other code below here that I forgot about for a second. So we see that we were able to get the last item on array. If we do the same thing with chars for characters, we get our E. So we've just created a customized method on the array. And that can be really useful when we find ourselves doing the same kind of logic on arrays over and over again. We could also, this is not advised, but we could also use this to troll. Let's say that we wanted to troll our fellow developers and change the definition of pop. So pop usually takes off the last item. In this case, actually, let's keep the code the same. So notice now that if we do characters.pop, we will get out that last item, but then if we look inside of characters, it's still there. So this is not good practice. We don't want to be overwriting existing methods, but now that we have this insider information about the prototype, we can if we want to. Maybe there's some good reason to do it. Maybe we're just being jerks, but that's something we can do. So now that we know about the prototype, we can use it to apply it to some of these other data types that we're used to using. So there's a little last look into some of the fun things we can do with this knowledge that we've acquired tonight. So I know that we've got a ton of questions that have been popping up in Zoom. I'm going to go ahead and call it for tonight on the new information so that we have plenty of time to explore this in the Q&A. I know this is a really cool, but also really complex topic. So I'm going to briefly go over the homework tonight, and then we will get to all of those outstanding questions. So the homework tonight is a little bit different. This is one of my personal favorite homeworks to write because I got to write some fun logic. So a lot of the homework so far has been oriented towards writing your own code, especially the JavaScript homework has been more about writing code. And yes, writing code is a super important skill. But one of the other really important skills that you'll do again and again in the job is reading code. So you'll start at a company and there'll be this gigantic code base that people before you have written. In some cases, and unfortunately a lot of cases, it will be crappily written and you will have to wade through it and figure out what's going on. In some cases, it will be brilliantly written and you'll have to try and figure out what's going on because it's so brilliant it goes over your head. Hopefully the homework tonight is more in camp too. But that's the idea behind the homework tonight. There's a lot of code that you're going to be receiving that I already wrote, and it's your job to try and understand it, maybe not perfectly, but understand it enough that you can use it. So let's take a look at that. I have created a class for you called HTML element. Once again, this is one of those weird things where we're not writing HTML code per se, we're writing JavaScript, but we're using it to kind of imitate HTML. So we have this HTML element class. It takes in a type and a text. There's a bunch of explanation in the comments. We have the constructor here. This should look kind of familiar. We have some methods on the prototype. There's one method called toString that is really complex. As I've said in the comments, you do not have to understand all of this code. In fact, you could probably waste a lot of time trying to understand toString. So don't worry too much about what's going on in here. Just make sure you know how to call toString. So then below here, we actually have a couple questions for you guys. So you'll be creating new instances, you'll be defining a new class name, and then in the stretch question, you'll be playing with that really crazy toString. So the stretch question is actually really difficult tonight. So play with it if you get a chance, but don't sweat it if it's a little tough. So that is the homework for tonight. You'll have a chance in just a minute to get that going and get with your groups. But let's go ahead and I'm going to dig through Zoom and see what questions we have and try and answer as many as I can. I will scroll to the top here. One second. Oh, one meta question about last night's lecture. So you might have noticed it's missing from YouTube. That is because it is just missing. So the last night's lecture and the iOS lecture got somehow mysteriously and unpleasantly merged into one. So, and unfortunately I wasn't recording it, which I apologize for. So it is gone forever. But if you want, I can link you, let me know in Slack and I can link you to the lecture from the last section, which contains basically the same thing. So there's a little meta note about a technical difficulty we had switching over to Zoom. Okay, so we have someone requesting clarification on the keyword this. So let me go over that again. I'm gonna get rid of that and go down here. So this is a really weird keyword in JavaScript. It refers to, it's basically saying there's going to be some object set equal to this when this code runs, but right now we don't know what it is. So for example, when we're calling the kill method, we don't want to be, even though the kill method is communal, every single instance has a new head count on it. And that's a good thing because we wouldn't want, when the character assassin kills someone, we wouldn't want our ninja assassin to be getting credit. So there has to be a separate copy of this head count property in every single instance, because even though they're starting at the same place, they're going to be presumably incrementing at different speeds. So in that case, we do have to create a unique copy because they will be incremented in unique ways. So to make sure that we're actually incrementing the correct head count, in some cases, when we run this code, we might want to increment ninjaassassin.headcount. And sometimes we might want to increment characterassassin.headcount. But we need to be able to write our rule book, write this function without knowing which instance it's going to apply to, because it will apply to different instances at different times. So we use the keyword this as a stand-in. And when kill is called on Ninja Assassin, the code runs it as if this line of code said ninjaassassin.headcount. When we call kill on the character assassin, this line of code is run as if it said characterassassin.headcount. So there's a little more detail on the keyword this. I will just say that the keyword this is one of those things that will make more sense as you write more code, read more code, get more familiar with it. So there's a couple tools for thinking about it to start, but if it doesn't totally gel right now, that's okay. That's kind of just the name of the game. So let's see what else we've got here. Okay, we have a question about the kill method. And so right now the kill method is auto set to just incrementing by 1. So we have to call kill every time there's a new kill. What if we wanted to customize it though? So maybe, actually we can't use numbers. So let's say that we have this parameter called X and we pass in how many people have been killed. So we could do this dot kill count plus equals X. So now instead of just incrementing it by 1, we're incrementing it based on the input. So here we could do ninjaassassin.kill and we could have him kill 5 people in 1 line. So if we console log our ninja assassin and run our code, we see that the head count is incremented. And let's say that next week he has a good week and kills 9 people. Now it's incremented up to 14. So that's just, that's just going to depend on how you're using your code. It might make more sense to have a kill method where you're just incrementing by 1. It might make more sense to have a kill method where you're passing in a value and incrementing by that amount. So a good question, an interesting opportunity to explore a different way we might write that method. Okay, so we have a question. Why is the prototype written outside of the main assassin class creation? So there are 2 different ways I can think of answering this question, so I'll do both. The first is just a reminder that we wouldn't want to define this.kill in here. So if we did this.kill, we're putting kill. There's no way to really access the prototype in here. Actually, technically, I've never tried this before. So let's do this. I wonder if this would work. Total crazy experiment right now. So I'm actually moving this line of code where we define what's on the prototype. Let's see if it works. It still works. So apparently, if we want to, we can put the prototype code inside of the constructor. I've never seen it done that way. It might just be a best practice thing. There might be a deeper reason why we don't want to do this that I'm not aware of. Interesting question, though. Got me to try something I've never done before. And one thing to note from what I just did is that you can, in fact, access the name of a function or a constructor from inside there. So this is a scope thing, kind of a side tangent. Because this exists in the global scope, the assassin constructor, you can access it anywhere, including inside of the assassin constructor. This concept makes something called recursion possible. I love recursion. Unfortunately, it's not part of WebDev 101 anymore. I'm very sad about that, but recursion is super cool and you will learn about it in the main curriculum. So little random plug for recursion there. And let me put this back. All right, so what else do we have? Okay, so another question about this memory issue. I kind of already addressed this, but I'm just going to say it one more time, which is that all 4 of these we're creating unique copies of. So all 4 of these we will be creating unique copies of in memory, and we have to because they'll be set equal to different values. So So we do need as much memory as we need to store what we're doing. There's really no way around that. If we have 100 assassins, we need 100 sets of information for each one. So the prototype is only for things that aren't unique, things that are going to be the same throughout all of them. So the kill function is exactly the same for all of them. So we can't perfectly save on memory because we need enough memory to store the info we have. But if you think about all those, for example, all those methods on the array, there are like 30 methods on an array. And think about creating 30 new copies of that method every time. And functions are going to take up a little more memory than something like a string or a number as well. So it's not a perfect memory saving technique because every instance is going to require enough memory for all its unique attributes. But we might as well save memory on the things that aren't going to be unique, like methods. All right, let's see. We do have a question about the homework last night, and I'll just say we don't normally do homework questions in the Q&A because we want to focus on the content of the lecture. If you're wondering about that, just post that in Slack after the lecture and tag me in it, and I'll address that in Slack individually. Okay. We actually had an interesting comment about why we wouldn't want to do this. So we had a suggestion about why we wouldn't want to do this. I don't think that, let me go over this idea one more time. So there was this comment about, wouldn't this defeat the purpose of saving memory because we're creating a bunch of different copies of it? Yes and no. So, but this comment did give me insight into why we don't want to do this. So thank you, Johan, for bringing this up. So what would happen every time this constructor was called is we would create a new version of this function and overwrite the old version. So basically we'd be running this line of code a bunch of times. So there wouldn't, let's say we created 100 assassins. There wouldn't be 100 copies of kill in memory per se, because every time we would be overwriting the old one, and then the old one would be cleaned up by garbage collection, but we would be running extra logic that we don't need to. So every time we create a new instance, we would be running this code and just kind of reinventing the wheel every time. Whereas if we keep it outside, then we only have to run this line of code once. So thank you for giving me a little bit of insight into why we wouldn't want to do that. I appreciate that. I learned something new tonight. A kind of meta question about tomorrow's lesson. Tomorrow's lesson is about callbacks and higher order functions. I won't get too much into what those are because that's what tomorrow's for. But I will say that it's going to be very meta and we are going to be passing functions into functions. So super fun, super weird, be there. Let's see if we have any more. Okay, we had a question about this array.prototype.getLast that I did. Let me bring that back and I'll just go over that one more time. So I had array.prototype.getLast. And I'm going to do this on one line this time, just going to return this at this dot length -1. Okay. So this was, as a reminder, this is a function that we're putting on our array prototype that will grab the last item off of our array. So it's like pop, except we don't delete anything. So first of all, just to think about this, it's really similar to any other function we've written. So we're just going to use this anonymous function syntax to define what it does and then store it into getLast.prototype. The biggest difference is that because it's on the prototype, because it's a method, we can use our this keyword. We know getLast is going to be called on an array, which means that we're allowed to use our this keyword to refer to whatever array we call it on. As far as how this works, when I create an array and I call array.getLast, as a reminder, the first thing that happens is it checks the array objects. Because remember, even though arrays are arrays, they're also secretly objects. So it's going to check this specific array object for a method called getLast. And it doesn't exist. This thing does not have a getLast method on it. So then, instead of giving up, it'll now look into the prototype being an object on the constructor, and it finds it. So it finds this getLast function, it'll run this, it'll replace the keyword this with this particular array, and in that way we can get the last item of our array using this custom-made method. We have a question about, for a new programmer, what language to start with. It's going to depend. I think that JavaScript is a really good starter programming language. I also think Python is a good starter programming language. So these object-oriented languages, things like C or Java, are a little more syntactically strict. You have to jump through a lot more hoops to get your code to run, both in terms of the syntax and in terms of having to compile the code yourself. So I did start in Java. It's not a bad place to go. Basically, I would say if you want to try and get a deeper understanding in what's really going on, but maybe get a slower start, I would recommend something like Java or C. If you just want to get up and running and worry about the details later, I would recommend something like Python or JavaScript. But really, it's just the hardest. The first language is always the hardest. So just pick one, go for it, stick with it. Once you have the first one down, the next ones are going to be a lot easier. All right, do we have any other questions? Someone said it's always sunny in Bisbee. That is either a joke about my name, which I appreciate. I do aspire to be more like Sweet D in any way I can. Unfortunately, I am neither tall blonde nor bird-like, so that's a little hard. And to respond to that more literally, it is not actually always sunny in Bisbee. There is a monsoon season that's going to be starting next month, which is going to be interesting. But that is a side note. So, all right, well, it looks like we're pretty much done with questions here. The homework tonight is a little tricky, so I will make sure that you have plenty of time for that. Thank you again for joining the class tonight. I'm both excited that we're coming to the end of this course and a little sad to see you guys go. I hope you've learned a ton. I hope you guys will be around tomorrow night for classes, or sorry, tonight with classes, for callbacks. And good luck on the homework tonight. Post your questions in Slack. I believe it was Lauren who asked the question about last night's homework. Ping me on that in Slack and I'll take a look at it. So have a great night, you guys, and good luck with the homework. I will see you next time.